now we'll start talking about stop and wait ARQ. Alright, we are done with other protocols as well. So this is the first one. Okay, so what ARQ stands for, this is the first thing. It stands for automatic or automated repeat request. Right, I'm not that good with the full form, so kindly bear with this thing. Okay, so we have seen other protocols that are there, that were there, that is the a simple one and the stop and wait. Now we have something that is known as stop and wait ARQ. What it means is, okay, what it means is that whenever some data packets are lost, okay, we are not going to wait for an infinite amount of time. Okay, so rather than that, okay, the moment our timer goes out, there is one thing that is known as timeout timer. The moment that timer goes out, what happens is the data would be transmitted once again. Alright, now what happens over, I'll give you a real world scenario. So let's say this is a sender, okay, and this is a receiver. Okay, this is how you I'll say draw straight lines. Okay, yeah. So what happens is sender and receiver is going to send some data. Okay, they are going to send some data, but the window size for your sender is equals to 1 and the window size for your receiver is also equals to 1. Okay, now let's say the data that they are trying to send is in some sequence number. So let's say this is my sequence number. Okay, similarly receiver is also having sequence number, but the window size is 1. It means it can only send one data packet, okay, and then it expects some acknowledgement for it, and this one can only receive one data packet at a time. Right, so what happens is, now this thing is clear that both the sender and receiver is going to have one window size or window size of 1. Okay, the moment a sender tries to transmit the data, okay, there is a timer involved over here, there is a timer added on. Okay, that timer is known as timeout timer. What used to happen in other stop and wait protocol is, it was not ARQ, it was only stop and wait protocol. Okay, so the sender, we have seen that this thing, that the sender was sending some data, okay, some data packet over the channel, and if that data packet is lost, they are going, both the sender and receiver are going to wait for infinite amount of time or for a larger amount of time, which is absolutely rubbish, and it was not the efficient utilization of services. Okay, so that's why they came up with stop and wait automated repeat request. Okay, it means if the timer goes out, the data would be transmitted once again. Okay, now let's say this is the point where data would be transmitting. Okay, this is the point of time from where data would be transmitted. Okay, the moment this data bit is placed over here, your timeout timer has been triggered. Okay, so this timeout timer value is decided on the basis of something on which sender and receiver agrees. Okay, that is, should be it should be the at least the amount of time in which the data can be sent and received. Okay, so the timeout timer starts. Right, now this data would be traveling. Let's say that data has been received, okay, this bit. Now what receiver is going to do is, receiver is going to send the acknowledgement back. Okay, and this, if this whole process is done correctly, it would be done within the timeout timer only. Okay, this is the best case scenario. Now the worst case. Let's say now the next data packet is being sent 0 okay, and it has been received. Sorry, not 0. I'll erase this one. Not 0, it was 1 being sent. Okay, why this pen is not working? Just give me a second. Yeah, so now it's working. So 1 has been sent successfully. The moment your receiver sends the acknowledgement back, the acknowledgement gets dropped due to some reason. Okay, so obviously the timeout timer would have been started here, and since the acknowledgement is not received, my timeout timer is going to be triggered, right? So the moment this timeout timer has been triggered, that okay, the alarm time has been done. Okay, we have waited for enough amount of time and we haven't received the acknowledgement back. Now what is assumed at the sender side? Even though the receiver has received this data, that is 1, sender would assume that this data was lost during the transmission. Okay, because the acknowledgement was not received, but your sender is not aware, no, that acknowledgement is not received and data has been received. Okay, so sender assumes that data has not been received, so what it needs to do is it needs to retransmit the data. So retransmission takes place. Now receiver was expecting something else, but it has received 1 once again. Now receiver is going to override the data and it would send the acknowledgement back. Again the timeout timer would be here. This is the second case, alright. Similar to this, we have third case in which the data packet is lost. So we are going to send 2 and let's assume data packet has been lost. Obviously the timer would have been started here. Since the data packet is lost, no acknowledgement would be there, so timeout timer would be done, right? So we will be done with the timeout timer. It would be triggered, which means now sender would once again assume that I have not been able to transmit the data successfully. So what I need to do, what sender needs to do, it needs to retransmit this data once again. Obviously the timer would start here, it gets the acknowledgement back, works fine. Okay, this is my overall third use case. Okay, earlier this one was my second use case, this one was my first use case. Now next I'll continue this channel. Okay, I'll continue this thing over here. Yeah, what I'll do is, now let's say at this point data would be sent or data would be sent. So let's say 3 is being sent, timeout timer is started here. For some, due to some incident, okay, or due to some congestion on the network, it took more time to send the acknowledgement, more time. But by this time your timer has already triggered. Now what would happen? It is going to reject this acknowledgement afterwards, okay, and it would retransmit the data again. So timer would be starting here, and since the data is being retransmitted, acknowledgement would be sent once again, and if that acknowledgement is received within the time, well and good. If not, retransmission takes place. Okay, now if you would see, now this is my use case number 4. Okay. Now if you will see the whole thing, okay, that's why it is known as automated or automatic repeat request. Right? If acknowledgement is not received, it is automating the retransmission. If data is not received by the receiver or data is dropped in between, sender assumes okay data has been dropped, retransmission takes place. If acknowledgement was received but it took longer than expected, or your timeout timer has been triggered by that point of time, retransmission takes place once again. Okay. So that's what we have with respect to stop and wait ARQ.